Welcome. Today we will see remaining part of the chapter 2, that is linearization of operating curves. Now we are knowing that many equipments are there. If we will plot their curve, that is input versus output, therefore every time we will not get a straight line, or there may be curves of combinations of 2 or 3 parameters. At that time, how to linearize the curves, that examples we will see. For example, you are knowing that for the different machines, speed is one parameter, then torque is there, that is another parameter. Sometimes fuel flow is there, that is also another parameter. Therefore, if there are such 3 to 4 parameters are there, therefore there will exist curves at different values. Therefore, how to linearize these curves, today we will see. Therefore, we will see example 1. I will read. The speed torque curve for the DC motor are shown in figure, where V is the applied voltage, N is the speed, and T is output torque. Determine the linear approximation for the change in torque small t due to change in speed small n and change in voltage small v. The motor drives an inertia load such that small t is equal to J into dN by dt, where J is the mass moment of inertia. For J is equal to 0.1, determine the differential equation relating to change in speed to change in voltage. Determine the time constant and steady state system gain. Therefore, this is our example. Now these curves they have provided. On y-axis speed is there, on x-axis torque is there, and this voltage is a function of speed and torque. See that these are the inclined lines are there. These lines are voltage lines, means voltage V is equal to 10, V is equal to 20, and V is equal to 30. Now in the diagram it has been shown that T mean or constant, means this vertical line, torque line at 50 or 50 Newton meter torque, this torque we have to take it as mean torque or constant torque. Similarly, N is equal to 100, this horizontal line we have to take it as mean speed or constant speed. Similarly, this middle line of the voltage, that is V is equal to 20, this line we have to take it as constant or mean voltage. And along these lines, whatever these mean lines are there, T mean, N mean or V mean, along these lines we have to find out the difference at these different points. Therefore, we will see the solution, then you will understand. Next, therefore solution. Therefore, what we have to determine? We have to determine T approximate, that is approximate torque, then second steady state system gain K, and third time constant tau. Therefore, here we have given non-linear function as small t is equal to J into dN by dt, or T torque is a function of speed and voltage, or you can read like this as T is equal to F of NV. This is the functional equation. Therefore, generalized linear equation is small t is equal to C1n plus C2v. This is equation 1. Therefore, how to find out values of C1 and C2? We will see in next slide. Now again we have to draw the graph because we have to find out the values. Now how to find out C1? C1 is equal to dou t divided by dou n when V is equal to constant, which is equal to dou t means delta t, dou n means delta n. Therefore delta t upon delta n when V is equal to constant. Now delta t means difference in the torque and delta n means difference in the speed when voltage is constant. Now which line of voltage is constant here? This line BC. Therefore along this line BC we will find out delta t and delta n. Therefore C1 is equal to Tc minus Tb, Tc minus Tb divided by, again delta n is equal to Nc minus Nb, Tc minus Tb divided by Nc minus Nb, which is equal to, now what is the value of Tc? Value of Tc is 75, value of Tb is 25. Therefore which is equal to 75 minus 35 divided by, what is the value of Nc? Nc is equal to 50 and Nb is equal to 150. Therefore 75 minus 25 divided by 50 minus 150. Therefore by doing the calculation we are getting C1 is equal to minus 0.5. Now we will find out C2. Therefore C2 is equal to delta t upon delta V when n is equal to constant, which is equal to delta t upon delta V when n is equal to constant, that is C2 is equal to dou t by dou V when n is equal to constant. This dou t means difference in torque, dou V means difference in voltage when n is equal to constant, which is equal to delta t upon delta V when n is equal to constant. Now what is the constant value of n? Constant value of n is nothing but this 100, line DE, line DE. Therefore this horizontal line is there, line DE. Along this line we will find out difference in torque and difference in voltage. Therefore C2 is equal to TD minus TE, TD minus TE divided by VD minus VE, VD minus VE, which is equal to 25. TD means 25, TE means 75. Therefore 25 minus 75 divided by VD. What is the voltage passing through the point D? V is equal to 10. Therefore 10 minus VE. What is the voltage passing through the point E? V is equal to 30. Therefore 10 minus 30 is equal to 2.5. Now we will substitute value of C1 and C2 in equation 1. Now before substituting values of C1 and C2 in equation 1, there may be question that why sir has taken only this Tc minus Tb or Nc minus Nb. If you will take Tb minus Tc and according to that you have to find out Nb minus Nc, still this answer will remain same. Similarly here, if you will take Te minus Td divided by Ve minus Vd, still this 2.5 answer will remain same. Therefore just you have to follow in one direction only, answer will remain same. It is not like that only this ratio if you take then this 2.5 will come, or this if you will take this ratio only at the time only minus 0.5 will come. It is not like that. If you will take Tb minus Tc divided by Nb minus Nc, still answer will be minus 0.5, and if you will take Te minus Td divided by Ve minus Vd, still answer will be 2.5. Therefore our equation 1 is there, T is equal to C1n plus C2v. This is equation 1. Therefore we have to substitute value of C1 here and value of C2 here. Therefore what is our equation 1? This is our equation 1. Therefore from equation 1 we have small t is equal to minus 0.5n plus 2.5 v. This is equation 2. Now they have given us another equation. First of all, we will find out T approximate. Therefore, approximate torque T is equal to Ti plus small t. Now, what is Ti? Ti is equal to 50. This is nothing but constant torque. Always remember, this Ti means mean torque or constant torque. Therefore, Ti is equal to 50. This value is taken from the figure, and small t is equal to this from equation 1, minus 0.5 n plus 2.5 v. Therefore, T approximate, we are getting it as T approximate is equal to 50 minus 0.5 n plus 2.5 v, equation 3. Now next, they have given us one equation in the problem itself, that is small t is equal to j into dn by dt, where j is equal to 0.1. Therefore, small t is equal to j into capital D into small n, where capital D is nothing but d divided by dt. Therefore, substituting value of j is equal to 0.1 in this equation, therefore t is equal to 0.1 dn, equation 4. Now what we will do? We have equation 2 here. Equation 2, what is our equation 2? Small t is equal to minus 0.5 n plus 2.5 v. And this is our equation 4. Small t is equal to 0.1 dn. Therefore, we will compare these two equations. Therefore, equating equations 2 and equation 4, we have minus 0.5 n plus 2.5 v is equal to 0.1 dn. Therefore, term related to n we have to take it on one side, term related to v we have to take it on another side. Therefore, which is equal to 2.5 v is equal to 0.1 dn plus 0.5 n. Therefore, 2.5 v is equal to n, we have to take common, small n into bracket 0.5 plus 0.1 d. Therefore, this n divided by v, we will take n divided by v. N divided by v is equal to 2.5. This term will go on this side, it will become divided by. Therefore n divided by v is equal to 2.5 divided by 0.5 plus 0.1 d, equation 5. Now what we have to do? Here in the denominator, always remember this first here value is there, this value should be equal to 1. Instead of 0.5, we have to obtain this value should be equal to 1. Therefore, what we will do? We will divide numerator and denominator by 0.5. Therefore, this is our standard form of equation for system gain and time constant. X divided by y is equal to k divided by 1 plus tau d, equation 6, where k is known as system gain and tau is known as time constant. Therefore, here also in the denominator first value is 1. Therefore, whatever this equation 5 is there, n divided by v is equal to 2.5 divided by 0.5 plus 0.1 d, equation 5. Therefore, here in the denominator we will obtain value 1. To obtain the value 1, we have to divide numerator and denominator by 0.5. See that how it is. Therefore, n divided by v is equal to 2.5 divided by 0.5 divided by 0.5 divided by 0.5 plus 0.1 d divided by 0.5. Therefore, by simplification or by calculation, we are getting n upon v is equal to 5 divided by 1 plus 0.2 d. Therefore, now we will compare this equation 6 and this equation 7. Now, by comparing equation 6 and 7, what we are getting? K is equal to 5, that is system gain, k is equal to 5, and this tau, that is time constant, tau is equal to 0.2. Therefore, again I have written here equation 6, x upon y is equal to k divided by 1 plus tau d, equation 6. Equation 7, again I have written n divided by v is equal to 5 divided by 1 plus 0.2 d, equation 7. Therefore, comparing equation 6 and equation 7, we get system gain k is equal to 5 and time constant tau is equal to 0.2. Therefore, this is our end of the first problem. Now, example 2. What is the example 2? The characteristic of engine engine are described by the family of curves shown in figure. Determine the linear approximation for the torque small t delivered by the engine when torque small t is greater than load torque TL. The axis T minus TL is used to accelerate the engine so that T minus TL is equal to J into dN by dt. For J is equal to 0.025, determine the differential equation relating the change in speed to change in fuel flow and change in load torque. Determine the differential equation relating change in speed N to change in fuel flow Q and change in load torque T, change in load torque TL. What is the time constant tau? Therefore, this is our example, and they have given us graphs also. Therefore, these are the graphs. Now, what these graphs? How to read this? On y-axis, Q is there, change in fuel flow. It is having values 40, 50, and 60. 50 is the Q mean or Q constant, that is line BC is nothing but constant line or constant fuel flow or Q mean or Q constant. Similarly, on x-axis speed is there. Three different speeds are there: 2000 rpm, 3000 rpm and 4000 rpm. Therefore, here 3000 is the mean speed. Therefore, line ED, this vertical line ED is nothing but constant line. Similarly, interaction of this speed and change in fuel flow is nothing but torque T. Three torque lines are there. BE is nothing but T is equal to 150. Similarly, line passing from point A, torque line, this T is nothing but 100, and line passing from the point DC, that is T is nothing but T is equal to 50. Therefore, out of these three torque lines, T is equal to 100 is the constant torque or the mean torque. Therefore, along these mean lines, that is N is equal to 3000, this vertical line, Q is equal to 50, this horizontal line, and T is equal to 100, this inclined line. Along these three lines, we will find out changes in speed, change in fuel flow, and change in torque depending upon the equation. Therefore, next solution, again what we have to determine? To determine T approximate, that is approximate torque, time constant tau, fuel flow Q, change in speed small n, and change in load torque TL. Therefore, here torque is a function of speed and fuel flow, that is T is a function of NQ. So, its generalized linear form is small t is equal to C1n plus C2q, equation 1. Therefore, we will find out values of C1 and values of C2 from the graph. Therefore, next, again this graph is there. What is our equation 1? Small t is equal to C1n plus C2q. Therefore, we will find out first of all value of C1. Therefore, C1 is equal to dou t divided by dou n when q is equal to constant, which is equal to delta t upon delta n when q is equal to constant. Therefore, C1 is equal to, now where q is equal to constant, what is the constant value of q? Constant value of q is 50. Therefore, along this horizontal line BC, or this along this horizontal line 50, we will find out this delta t, that is change in torque, divided by delta n, that is change in speed. Therefore, we will take this line BC as the horizontal line, reference line. Along horizontal line, we will find out change in torque and change in speed. Therefore, C1 is equal to TC minus TB divided by NC minus NB, which is equal to, what is TC? TC is equal to 50. 50 minus TB is equal to 150. Therefore, 50 minus 150 divided by NC. NC is equal to 4000 minus NB is equal to 2000. Therefore 4000 minus 2000 is equal to minus 0.05. Now again there is a question that why I have written TC minus TB or NC minus NB. You can write TB minus TC also divided by NB minus NC. Still answer will remain same. Now we will find out value of C2, that is when speed remains constant. This speed remains constant. Therefore C2 is equal to dou T divided by dou Q when N is equal to constant. What is the constant value of N? 3000. Therefore along this vertical line we will find out dou T and dou Q. Therefore dou T means delta T and dou Q means delta Q. Therefore dou T upon dou Q when N is equal to constant is equal to delta T upon delta Q when N is equal to constant. Now what is constant value of N? 3000. Constant means mean value. Constant means mean value. Therefore at this 3000 we will find out delta T upon delta Q. Therefore delta T is equal to C2 is equal to TE minus TD, TE minus TD divided by QE minus QD, which is equal to TE. What is the value of TE? Torque line passing from point E? 150. 150 minus what is the torque value of the torque passing through the point D? 50. Therefore which is equal to 150 minus 50 divided by what is QE? QE is nothing but 60. Therefore 60 minus what is QD? QD is equal to 40. Therefore 60 minus 40 is equal to, by performing calculations we are getting C2 is equal to 5. Therefore substituting values of C1 and C2 in equation 1 we are getting, what is our equation 1? Directly equation 1 is there, small t is equal to minus 0.05 N plus 5Q, equation 2. Therefore again we will find out T approximate torque. T approximate is equal to Ti plus small t. Therefore T approximate is equal to, what is the value of Ti? Means mean torque is nothing but 100 minus this small t value we have to write down from equation 2. Therefore 100 minus 0.05 N plus 5Q. Therefore they have also given us one equation in the problem that T minus TL is equal to J into dN by dt, where J is equal to 0.25. Therefore T minus TL is equal to 0.25 dN, where capital D is nothing but d divided by dt. Therefore T is equal to 0.25 dN. This TL will go on this side. Therefore small t is equal to 0.25 dN plus TL, equation 3. Therefore now we will compare equation 2 and 3. Therefore this is our equation 2, small t is equal to minus 0.05 N plus 5Q. This is our equation 3, small t is equal to 0.25 dN plus TL, equation 3. Therefore comparing these two equations or equating these two equations, what we are getting? Equating equation 2 and equation 3 we get minus 0.05 N plus 5Q is equal to 0.25 dN plus TL. Therefore rearranging the terms we are getting 5Q minus TL is equal to 0.25 dN plus 0.05 N. Now taking again N common from this right hand side, therefore 5Q minus TL is equal to N into bracket 0.25 D plus 0.05. Therefore N is equal to, take this term on this side, N is equal to 5Q minus TL divided by 0.25 D plus 0.05, equation 4. Now this equation 4 we will obtain in terms of the equation x divided by y is equal to k divided by 1 plus tau d. Then we will find out value of k, that is system gain, and tau means time constant. Therefore next, comparing equation 4 with the standard form for time constant and system gain, that is x divided by y is equal to k divided by 1 plus tau d. Now again equation 4 we will write. This is our equation 4. N is equal to 5uq minus TL divided by 0.025 d plus 0.05. Now here value of 1 is there in the denominator in this equation. Therefore here we will obtain value 1. Therefore what we will do? We will divide numerator and denominator by 0.05. Therefore n is equal to 5uq divided by 0.05 minus TL divided by 0.05 divided by 0.05 divided by 0.05 plus 0.025 d divided by 0.05. Therefore n is equal to 100q minus 20 TL divided by 1 plus 0.5 d. Therefore comparing this equation, n is equal to 100q minus 20 TL divided by 1 plus 0.5 d. Comparing this equation with this equation, we are getting system gain k is equal to 100q minus 20 TL and small tau, that is time constant tau, is equal to 0.5. Okay, we will stop here. Again in next lecture we will see another more problems. Thank you very much.